Hello Year 10. Today we are learning about lines and parabolas, or more specifically, when lines and parabolas intersect. So a quadratic is a parabola. There are three possible types of things that can happen if we have a parabola and a straight line. First of all, the straight line can pass through the parabola in two places. That would look like this. We have a parabola and the line cuts through it in two spots, here and here. Second option is that the parabola touches the line in only one spot, so that means that the line is tangent to the parabola, which looks like this. We have our parabola, we have our line coming down, and it's just touching at that one point where the line is a tangent to the parabola. And option 3 is that the parabola and the line don't touch at all. So the parabola is either completely above the line, or it could be switched over so that the line is above the parabola if the parabola was concave down. So there are our three options: 2 points of intersection, 1 point of intersection, or no points of intersection. And we would need to determine which one of those is the case and then hence solve to find any points of intersection. Some other words that we need to know: if a line cuts through a parabola twice, it is called a secant. So this line going through here is called a secant because it cuts through the parabola twice. And if the line touches the parabola once, the line is called a tangent. We did talk about that one already. Remember to write either the quadratic equation or the linear equation in terms of y. So in other words, get the y by itself so that you can substitute it into the other equation. So because one of our equations is a quadratic, we can't use the elimination method. We will be using the substitution method every time. So that means we need to always have an x or a y. It's usually the y that we want by itself. Then we solve the quadratic to get either our 0, 1, or 2 solutions. And then we also need to find the y values that go with the x values that we've just found. All right, so let's work through those steps for these questions. Question 1, find any points of intersection for y equals x squared plus 3x. That's equation 1. And y equals x minus 2. That's equation 2. So in both of those equations, I have y equals. I am going to sub equation 1 into equation 2. So that means that the x squared plus 3x is going to replace the y in that second equation, so that it would look like this: x squared plus 3x equals x minus 2. Okay, then I want to get everything onto the left-hand side of the equation in the correct order for my quadratic. So I want the x squared first. The 3x will be next. So I'm going to move the other x from the right-hand side over. So that means I need to subtract x to get 2x. And then I want to move the negative 2. It needs to move across the other side. So it will become a positive 2 equals 0. Okay, now that it is a quadratic, I want to solve it. And at a quick glance, I go, what times to give 2 and adds to give 2? Oh, well, 1 and 2 makes 3, so that doesn't work. So it doesn't look like it's something that I can factorize. So I'm going, oh, maybe this doesn't even have any solutions. So if we're not sure, what we can do is use our discriminant to check to see if there are any solutions. So A will be 1, B is the 2, C is the other 2. So subbing in, I would get 2 squared minus 4 times 1 times 2. And that equals negative 4. Okay, so as soon as I see that that's negative, it's confirmed in my mind that even if I use the quadratic formula or completing the square, I would not be able to solve that quadratic, which means, therefore, there are no points of intersection. Okay, so that's all you would need to write, but just to give you a little visual, this is one of the questions where we have a concave up parabola and we have a line like that, and they do not touch at all. Let's try another one. Question B, y is equal to x squared plus 9x plus 10. That will be equation number 1. And y is equal to 2x is equation number 2. Okay, so I'm ready to do a substitution. I'm going to sub equation 1 into equation 2. So all of this is going to replace the y in that equation, which will give x squared plus 9x plus 10 equals 2x. Then let's move everything to the left. So we'll have x squared. When I subtract the 2x over, I will get 7x plus 10 equals 0. And okay, looking at that, what times to give 10 and adds to give 7? It would be 2 and 5. So this one I can see straight away that I can factorize it. So no need to use the discriminant because I can see the solutions. So I've factorized it. From the first bracket, I will get x is equal to minus 2. From the second bracket, I will get x is equal to minus 5. I will need to sub those back into one of the original equations. It'd be easiest to put it into equation 2 because it's much shorter. For x equals minus 2, I would get y equals 2 times minus 2, which is negative 4. If x equals negative 5, y would equal 2 times negative 5, which is negative 10. So therefore, there are 2 points of intersection. The first one is negative 2, negative 4, and the second one is negative 5, negative 10. Part C. We want to solve these, and it does give us a hint to give an answer in exact form. That gives an indication that maybe the solutions of this aren't nice whole numbers, so factorizing might not be an option here. So we have equation 1 and we have equation 2. We are going to sub equation 1 into equation 2. That would give x squared minus x minus 1 is equal to 2x. Subtracting the 2x over, we would get x squared minus 3x minus 1 equals 0. And if I look to try to factorize, what times is to give minus 1 and adds to give minus 3? Nothing. So I can't factorize it. I could use the discriminant to check, but given that it said I want answers in exact form, I'm going to take a little bit of a gamble here and go straight to the quadratic formula. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So I am using this here. So a would be 1, b is minus 3, and c is negative 1. Subbing in to my quadratic formula, I get minus minus 3, which is just 3, plus or minus square root of negative 3 squared minus 4 times a times c all over 2 times a, so 2 times 1. Underneath that square root, negative 3 squared is 9, and minus 4 times minus 1 is a plus 4, so I have 9 plus 4 is 13. So you can use your calculator for that if you want to, but that's equal to the square root of 13 over 2. So in exact form, my x solutions are 3 plus square root of 13 over 2, or the second solution is x equals 3 minus square root of 13 all over 2. The y values that go with that, and again, I'm going to sub into a line because that's much easier. I just have to times it by 2. So to find the y values, I would have 2 times by the 3 plus square root of 13 over 2. That's going to cancel the 2 from the top with the 2 on the bottom, and so y is going to be equal to 3 plus root 13. Similarly, for the other one, to find the y value, I'm timesing the 2 with the 3 minus root 13 over 2. The 2 out the front, will cancel the 2 from the bottom, and we'll get y equals 3 minus root 13. So to put that in the form of a point, our 2 points are going to be 3 plus root 13 all over 2, comma, 3 plus root 13. That's my first point. The second one is 3 minus root 13 over 2, comma, 3 minus root 13. So it looks pretty yucky with all those surds in there, but I've managed to get my answers in exact form. Okay, one more question, D. We have equation 1 and we have equation 2. We are going to sub equation 1 into equation 2. Okay, so that's going to give 8 minus x squared over 2 equals 2 bracket x take away 1. So to tidy this up, I'm going to times the 2 from the bottom of this fraction over to the other side, which means I just need to multiply it with the 2 from the front to make a 4. Then I'm going to expand out and move everything in order to make a nice quadratic. Now, the x squared is currently negative, so I'm going to be moving everything to the right-hand side to become a positive x squared. We already have a positive 4x, and we need to subtract the 8, so I have minus 4 minus 8 would be negative 12 is equal to 0. Then, can I factorize? Can I find two numbers that times to give negative 12 and add to give a 4? Yes, the numbers would be a positive 6 and a negative 2, which means that x equals negative 6 or x equals 2 would be my solutions. And then I would sub back in to find the y value. So again, I'm going to sub into my straight line. So it's going to be 2 times bracket minus 6 minus 1, so that's 2 times minus 7, which is minus 14. And then the other one, we're putting 2 times 2 minus 1, so 2 times 1 is 2, which means that my points are negative 6, negative 14, and 2, 2. Okay, time for you to try these and work on exercise 7G.